Welcome to EDU World Space.
Problem 3.107. In this problem, we have to calculate the value of A for which resultant of all these forces that are acting on this beam will be at maximum distance from the support A. So let us first draw the equivalent diagram for this system. So this was support A and this was support B, and let's say our resultant force is R, that is at a distance x from the support A. So we have to find the value of A for which the value of x is maximum. For that, first of all, let us calculate the value of R. So what is the equivalent force that is acting on the system? So considering the downward direction to be positive direction, so it will be 1300 plus 400 plus 600 minus 400 multiplied by A upon B. In this problem, value of B is given as 1.5 meter. So here R comes out to be 2300 minus 400 A upon B. So let us consider this to be first equation. Now we can balance moment in equivalent diagram and in real diagram about any point. So here we are going to consider the moment about point A. So if we calculate moment about point A in equivalent diagram, since this R is going to cause a clockwise couple and I am considering the anti-clockwise couple to be positive. So this will be minus R multiplied by x. And if this moment should be equal to the moment that is in this actual diagram about the point A. So if we calculate moment about point A, so the moment because of this 1300 Newton will be 0 since it is passing through the point of our calculation, that is point A. So this will be 0. This 400 A by B, this force is going to cause an anti-clockwise couple. So it will be positive A upon 2 force multiplied by perpendicular distance. So that is 400 A upon B. Now, talking about the moment because of this 400 Newton, this will cause a clockwise couple. So it will be minus 400 multiplied by A, and the moment caused by this 600 Newton will be clockwise. So negative 600 multiplied by A plus B. So from here we can get the value of x. So x comes out to be, this will be 400 and this 2 cancel out this 400 to be 200. So it will be 200 A square upon B, and this is minus 400A and this will be minus 600A. So total will be minus 1000A and this will be minus 600B whole divided by minus R. And we have calculated the value of R in terms of A in equation 1. So by using equation 1, we can write the value of x to be x is equals to 200 A square upon B minus 1000 A minus 600B divided by 2300 minus sign, so it will be minus 2300 and plus 400 A upon B. So this is our second equation. Now we have to maximize the value of x, and here the only unknown in right hand side is A because value of B is given in this problem as 1.5 meter. So to maximize the value of x, we can differentiate x with respect to A and we will equate it to 0. So this will give the value of A for which x will be either maxima or minima. So let's just go for that. So by differentiating, both the sides. So this will be dx upon dA, and this will be differentiation of, we can use this rule, differentiation of u upon v. This gives u dash v minus v dash u upon v square. So we will use this, that first we will differentiate the numerator and keeping the denominator constant. So if we differentiate numerator with respect to a, so the first term comes out to be 400 a upon b minus 1000, and since this 600b is a constant term, so its differentiation will be 0 multiplied by the denominator, that was minus 2300 plus 400 a upon b minus, now differentiating the denominator, so first term this will give 0, and since it's a constant, so differentiation of this 400 a by b will be 400 upon b multiplied by numerator, so numerator was 200 a square upon b minus 1000 a minus 600 b whole divided by minus 2300 plus 400 a upon b whole square. Now for maxima or minima, this should be 0. For maxima or minima, dx by dA should be equated to 0. So if we equate this term by 0, so this denominator can be sent out in the right hand side, so it will become 0. So our equation will be 400 a by b minus 1000 multiplied by 400 a upon b minus 2300 minus 400 upon b into 200 a square upon b minus 1000 a minus 600 b equals to 0. So we can collect here. Alright, so we can multiply this term by this whole bracketed term, so this comes out to be this 400 multiplied by 400, so this will be 16,000. Okay, we can do one more thing, that we can collect the coefficient, we can collect here 100 from each of them, so it will make our calculation easier. So if we take 100 out of this box, so this will be 100 multiplied by 4a upon b minus 10 into, and again taking 100 out of this box also, so this will be 4a upon b minus 23 minus this 4 upon b into 100, and taking 100 from this box also, so it will be 100 multiplied by 2a square upon b minus 10a minus 6b, and that is 0. So we can send these terms in the right hand side, so it will be 0, so it is going to reduce our calculation. Now we have to multiply this term by this term, so first term will be 4a by b multiplied by 4a by b, this is 16a square upon b square minus 23 multiplied by a upon b multiplied by 4a upon b, and the second term will be minus 40a upon b, and this will be plus 2300, and here this will be minus 8a square upon b square, this term, second term will be plus 40a upon b, and this term will be plus 24, and since b and b will cancel out, So we can write it here. So we can collect the coefficient of a square upon b square. So this comes out to be minus 8 a square upon b square So by collecting the coefficient of a square upon b square, this comes out to be minus 8 a square upon b square plus 92 a upon b minus 254, and that is equals to 0. Now value of b is given in this problem, and this will form a quadratic equation in terms of a. So we can get the value of a, and the value of a comes out to be 10.34 and 6.906. Now if we observe these values, that is the root of the equation, root of the quadratic equation that is found here. So a has the value 10.34 and 6.906. So if we observe our actual diagram, if a is 10.34, then it will exceed the point b, since distance between a and b is 9 meters. It means that our value 10.34 is not acceptable here. So the value of a that is acceptable here is 6.906 meter. It means that at a is equals to 6.906, our resultant force will be at maximum distance from point A. That was our demand of the first problem. Now talking about the second part. So in second part, they are asking to calculate. So in second part, they are asking to calculate the magnitude of the equivalent force and its point of application on the beam. So for the calculation of equivalent force, we have got the value of A. We can use this relation, that is equation 1, and we can get the value of R. So R comes out to be, R is equals to 2300 minus 400 A upon B, and if we put the value of A and B here, so it will be 2300 minus 400 multiplied by 6.906 divided by B, and B is given as 1.5. So this comes out to be the value of A. You can use the calculator, and it comes out to be 2300 minus 400 multiplied by 6.906 divided by 1.5, and it comes out to be 458.4 Newton. So we got the value of equivalent force. Now for the calculation of the distance from the point A, so we can use the second relation that we have obtained here, the value of x in terms of A and B. We have got the value of A, and B is already given, so we can calculate the value of x. So we can, by using second relation, x is equals to, we can use this entire relation. So this will be 200 multiplied by 6.906 divided by B, that was 1.5. This term will have 4 square minus 1000 A, and A is 6.906 minus 600 multiplied by 1.5 whole divided by minus 2300 plus 400 multiplied by A upon B, and A is 6.906 divided by B is 1.5. So if we calculate this value, it comes out to be 3.156 meters. So this is the distance from point A where the resultant force R should be applied to get the equivalent system.